Okay, so now we're back to looking at what happens with our rational exponents. Okay, so um, wait, before we do that, let's just look at the definition of a rational exponent. Okay, x to the 1/4 power. Okay, that's going to be the same as the fourth root of x. Okay, now what is a fourth root? Well, let's say we had something like the fourth root of 16. Okay, what we want to know is what number times itself 4 times gives us 16. Okay, so we need to find a number that multiplies times itself 4 times in order to get 16. The answer is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay, 2 to the 4th power equals 16. Okay, so we end up actually 2 to the 4th power equals 16, right? So I could say that I could substitute 2 to the 4th power under this fourth root, and instead of having the 16 there, I have 2 to the 4th power there. And you see what happens is a fourth root is going to cancel a fourth power. This will cancel this, and you'll end up with just 2. Okay, so all of that to say that the fourth root of 16 equals 2, right? Which means that 16 to the 1/4 power equals 2. Okay? And here we go again. Since 2 to the 4th power, the fourth root of 2 to the 4th power is 2. That means that we need to say that 2 to the 4th power times 1/4 is got to equal 2. And that works because, remember, we multiply when you've got something inside the parentheses and something outside of the parentheses. When you're raising a power to a power, it's multiplication. So this ends up being 2 to the 4th to the 1/4 power is the same as 4 times 1/4. Remember, we multiply the tops there. 4 times 1/4 is 4/4. Okay? 4/4. So that's the same as 2 to the 1st power, which is 2. So that's how this whole thing works. That's why the definition is the definition. So, oh, and then there's that weird thing where anything to the 1/2 power equals the square root. Okay? There really should be like a little 2 there, but there's not because the first root of something doesn't exist. So the square root is the common root. So that's the thing that you are going to see being the thing that's understood. If you just see a root of something, that means that it's to the 1/2 power. It's just like you never see 1x, right? Okay? If you just have an x, it's just one time. So that's what that whole thing is about. All right, so let's get back to business here. Whoops. 4 to the 1/2 power is the same as the square root of 4, which is 2. Number 2, 8 to the 1/3 power is the cube root of 8. So what number times itself 3 times, what number, like it's something times something times itself equals 8, right? Well, it turns out being that 2 times 2, which is 4, times 2 is then 8. So the answer to x to the 1/3 power is 2. Okay, great. Now there's this other thing. What happens if you have something like x to the 2/3 power? Okay, well, basically that's the same as x to the 1/3 power raised to the 2nd power. Okay, why? Because remember, when you raise a power to a power, it's multiplication, and 2 times 1/3 is going to be 2/3, right? So when we get to number 3, 27 to the 2/3 power, okay, what that's going to look like, okay, I didn't do this right, but that's going to look like the cube root of x squared, or you could also call it the cube root of x squared. Either way works. In this case, we're going to take the cube root of 27 first, because it has a cube root, and then square it. Okay? Well, the cube root of 27, 3 times 3 is 9, 9 times 3 is 27. So the cube root of 27 is 3, and I just square that. So my answer is 9 for that. Number 4, 64 to the 4/3 power. Actually, 64 has a cube root. The cube root of 64 is 4. Okay? So we're going to end up with 4 to the 4th power. Well, we already know that 4 cubed is 64 because we just undid it like that, right? So now we just need to do 64 times 4. 4 times 4 is 16. 4 times 6 is, I believe, 24. So 256. So the answer is 256. And that's how that goes. Alrighty.